because we use the putter more than anything in a bag. You know, anywhere between 30 to some players 40 times around.
And stability was the idea behind the new truss design as well?
Yes, so everything that we've done in performance, it starts with stability. So this here does not change, right? This is the impact location. And when you have a standard blade putter like this, you have deflection because you don't have the deep CG here that makes it more stable. So one of the things we wanted to work on is how can we improve. We're not going to get more stability other than through the hosel. We're not going to get a deep CG here. We're not going to get a high moment of inertia or an MOI like Spider does. But how can we attack this customer in a way, because he wants to look at this same shape here. That's what's important to him, is the shape. So the only way to do that was through the hosel. So if we can develop a hosel that maintained that shape, and that's what led us to truss. So when you look at the hosel, when you still look down at it, it looks like a classic putter. It doesn't look any different than this. But when you turn it on its side, and you look at it from the back here or from the front, it's different. And what's different is this creates a different type of stability, less twisting, especially when you're hitting it off center.
So do you have any digit to prove that it's more stable?
Yes. So we do a lot of testing. We do a lot of robotic testing. We do everything that tests exactly impact location. So we can measure the amount of flex or deflection that we see. So with a normal putter, on a 20 millimeters, which would be right about here. Remember, this is 28 for 5 handicap and below. Right here, when you impact this location, you have deflection over a 1 degree. Now, on a 14-foot putt, that hole is only 0.8 degrees, left or right. So at 1 degree, you've already missed the hole. We saw our deflection go down to 0.39. And then the center shaft of models that we have, because we created even more higher moment impact location, a better, less twisting. 80% improvement here, 60% improvement. Now the best of them all, I think, is, we have these two classic designs, a blade and a mallet. But what I just got back from testing with the tour players and up at Pebble was this one here, where we can take the truss, go all the way to the toe, to the heel. Now we create really an incredible center shaft that has less twisting. Most center shafts have one impact location. It's designed through the middle. Now we have stability all the way from heel to toe.
Do you feel like you take the same risk you took with the Spider 11 years ago?
It feels like it. It feels like it because this is a big change. In order to attack this type of player, they're so used to this for many, many years. We had to attack it in a way that still looked like it was classic. And it's a classic user. We had to attack it in a way that we didn't want to change the size or the shape. So when you look at this still looks like a normal classic putter. That was most important. And then that's why the shape of the truss, it's used in everything that we see today in architecture. So it's a load-bearing shape. In other words, you have a lot of unsupported area right here, right? It's only supported right here. Great example is tennis rackets. I'm old enough to know that when tennis rackets used to have one contact point, back when Rod Laver played, and you had the one contact point, and it was very unstable when you hit it off center. Today, tennis rackets are built with a truss design, right? They have 2 contact points on the racket, and that creates more stability. And that's what we're trying to do here, 2 contact points versus 1 contact. So all it's doing is creating, it's moving the less support that we have out here and creating more support on top, so creating less twisting.